Okay, so while dopamine, serotonin, norepinephrine, acetylcholine, even histamine, are kind of, hot neurotransmitters. They're neurotransmitters you've heard of, right? They're the ones that we have a lot of drugs targeting them. Dopamine, I should mention, of course, is, typically released, in response to many, or the dopamine system is, kind of stimulated in response to many drugs, like alcohol, cocaine, caffeine, nicotine, any drugs that are, that have potential for abuse, right? For example, um, well, even so, these modulatory neurotransmitters are very, very important. Obviously, there are two other neurotransmitters I want you to have some familiarity with that are kind of like the workhorse neurotransmitters in our brains. I mean, they carry, it turns out, the majority of excitatory and inhibitory messages in the central nervous system. So yes, dopamine is very important. All these other neurotransmitters are exceptionally important. But when you have excitation, when one neuron is carrying an action potential, and there's a neurotransmitter release that then excites the next neuron to generate an action potential, right? When you have an excitatory, influence over the next cell, the neurotransmitter in question is almost always what we call an amino acid neurotransmitter, because it's very, very, it's pretty much the same as one of our 20 amino acids, known as glutamate. Glutamate is the primary excitatory neurotransmitter in your brain, and glutamate is basically excitatory because it binds, of course, to postsynaptic receptors, right, that are ionotropic and open a hole, right, that lets some kind of depolarizing current, pass through. So typically it opens channels that let sodium and sometimes, in some cases, calcium go through. In contrast to glutamate, another very closely related, actually, in fact, the second neurotransmitter is actually manufactured from glutamate. It's a very yin-yang kind of an arrangement here. Another neurotransmitter called GABA is typically released at synapses where the effect on the next neuron will be to inhibit further firing. Of course, it's going to act, right, at a receptor. This receptor, GABA acts at receptors that are ionotropic, that open channels that allow for ions to pass through. But instead of depolarizing and exciting the next cell, right, generating a new action potential in the next neuron, GABA receptors open channels that permit chloride ions to pass through. And remember, chloride is a negatively charged ion, and it will tend to enter, because of the concentration gradient force, that postsynaptic cell. It'll enter the cell, and if by bringing more negative ions inside the cell, you are going to be increasing the charge difference between the inside and out. So you're going to go from minus 65 at rest to like minus 75 or minus 80. You are hyperpolarizing that next cell and making it less likely to fire. Interestingly, there are some drugs that are very popular that actually act at GABA receptors, postsynaptic GABA receptors. Alcohol is one, which basically acts like GABA to some extent at that postsynaptic GABA receptor. It causes it to open and allow for chloride to pass through, and it hyperpolarizes that postsynaptic cell. So alcohol can have that sort of calming effect to some extent. Although paradoxically, it tends to calm networks of neurons that are located in your frontal lobes, which we'll see are very important for inhibiting inappropriate emotional expression, making good social decisions. Alcohol and GABA, and they're in high, a lot of firing. They inhibit these areas, and so you can end up, dancing on the table. You're less inhibited when you hyperpolarize or reduce networks that are important for making good social decisions.